Welcome learners to my kcse revision channel. Teacher James Marita, Kilgoris Boys High School. Kindly subscribe to my channel. Click the notification bell such that you get notified once I upload a new video. Today we are looking at the industrial process called the Ostwald process. The Ostwald process is the large-scale manufacture of nitric 5 acid. So we have the laboratory preparation and then we have the industrial preparation. Industrial preparation normally is represented by the use of the flowchart of what I have here. So in any case, we have an industrial process. First of all, you need to identify the raw materials required in any industrial process. So the raw material required for the preparation of this nitric acid, raw materials, we have air. So we have air as the first raw material, then we have ammonia, and then we have water. These are the raw materials required in the preparation of this nitric acid. So we have air as the first raw material, then we have ammonia, and then we have water. So if you are required to identify the raw material, there are normally three, that is air, ammonia, and water. So in these steps now we have various steps that takes place here. So we have the purification, we have the compression, we have the heat exchanger, we have the catalytic chamber, we have the oxidation chamber, and finally we have the absorption towers where which is the final formation of in this nitric acid. So in the first stage we are saying that the raw material starts air and ammonia in this case is obtained from the HAPA process. So the sources of ammonia you get it from the HAPA process. HAPA process is the large scale manufacture of ammonia. So you take ammonia from HAPA process and air in the purification chamber, in the purifier. So what is happening in the purification chamber? The ammonia air mixture is just purified. Purification is done to remove the dust particles and impurities which might poison the catalyst. So if the impurities will not be removed at this purification stage, then the impurities will just poison the catalyst. And in this case here, that the impurities normally removed here, we talk of the dust particles. Why the dust particles? Because we have this ammonia. Ammonia is just a gas. And then we have this air. Air is a mixture of gases. So mixture of gases here, the impurities normally present there, we talk of the dust particles. So they are removed at the purification stage to prevent the poisoning of the catalyst. Then we have a pure air and ammonia. A pure air and ammonia are now passed in the compression chamber. In the compression chamber here, we have the air ammonia mixture is compressed. It is compressed at 9 atmosphere. So after compressed at the 9 atmosphere, the ammonia air mixture is passed through the catalytic in the heat exchanger. In the heat exchanger chamber here, there are some conditions required for the reaction to take place. So here we have the conditions required in the heat exchanger and of course the catalytic chamber. In these two we have the conditions required for some of the reaction to take place there. One, we have a platinum catalyst. This platinum catalyst, it is mixed with rhodium. The rhodium in this case, it is acting as a promoter. Then we have another condition of 9 atmosphere. Of course, the 9 atmosphere pressure you can see at the compression chamber. And then we have a temperature of 900 or 700. This temperature normally takes place. We have this temperature in the heat exchanger. Now, what is the role of the heat exchanger? The role of the heat exchanger, it provides the reactants with enough energy to react. And in this case, the reactants we have ammonia and then we have air. So they are taken in the heat exchanger to be provided with enough energy for them to react. And again, the heat exchanger, it can cool the product. Once air and ammonia combine, they will form a product. In that case, a product of nitrogen, a product of nitrogen one oxide, and in this case, water vapor. So what happens here? The product needs to be cooled. So if they need to be cooled, they will be taken back into the heat exchanger. So the roles of the heat exchanger, it is to provide the reactants with enough energy for them to react. It can cool the product. It can also sustain the reaction temperature. So when we have ammonia and air at 9 atmosphere, they are taken into heat exchanger. What is happening there? The mixture is preheated at a temperature of 900. So the temperature in this case increases. Initially, the temperature is around 200 or 230 or 240. So once the ammonia air mixture is introduced in this heat exchanger, they will be preheated. So the temperature will just increase from either 230 to 700, or in this case 900. So in that case now, the temperature in this case is required to initiate the reaction. A temperature of 900 or a temperature of 700 in this case is required to initiate the reaction. So we have now once the air has been provided with enough energy for them to react, and remember the reaction has not taken place. So we have a compressed air and ammonia. They are taken in the catalytic chamber. In the catalytic chamber here, you need to know the name of the catalyst. And the name of the catalyst here is called the platinum catalyst. A platinum catalyst is mixed with the rhodium catalyst. It's mixed with rhodium. In this case, rhodium, it is acting as a promoter. And what is the purpose of this catalyst? A catalyst normally increases the rate of the reaction by lowering the activation energy. You will get the factors affecting the rate of the reaction in a topic in Form 4. So we have a catalytic chamber here. The reaction now will take place. The reaction will take place in the catalytic chamber. The ammonia air mixture is passed through the platinum rhodium gas catalyst and heated at a temperature of between 700 and 900. So what will happen here now? The reaction will normally take place in the presence of that catalyst, whereby now ammonia will combine with oxygen to form the nitrogen 1 oxide, and then we have water. So ammonia is being oxidized to steam. So we have ammonia is oxidized to steam, and then we have the nitrogen 1 oxide. So this mixture here, which is this nitrogen 1 oxide now, which is very hot, and nitrogen 1 oxide which is very hot, and air, they are taken back in the heat exchanger. In the heat exchanger here, we have said that it normally has two main purposes. That is to heat the incoming air and also to cool the product, or to sustain the reaction temperature. So what will happen here, a hot nitrogen 1 oxide and air, they are now taken back in the heat exchanger, where now they will be cooled. They will be cooled now. The temperature reduces as low as 45 degrees. So at this point here, they will be cooled at low as 45 degrees. Why do we have at this low temperature? The low temperature is to ensure that there is a high yield of nitrogen 4. There is a high yield of nitrogen oxide. So this one, once they are taken in the heat exchanger, now they are cooled. Now we have in the oxidation chamber. In the oxidation chamber, oxidation is normally the addition of oxygen to a substance. So we have this now, the nitrogen 1 oxide, and then it is added, we have a purified air. So we have a purified air, and then we have the nitrogen 1 oxide in the oxidation chamber at this low temperature of 45. Then the nitrogen 1 oxide is oxidized by excess air to a brown nitrogen 4 oxide gas. So this is the reaction that takes place in the oxidation chamber. We have now the nitrogen 1 oxide, where it is being oxidized by excess air, a purified air. Then this one is oxidized to nitrogen 4 oxide gas. The nitrogen 4 oxide gas now from here, and the unreacted air. So we have unreacted air, the nitrogen 1 oxide and nitrogen 4 oxide now. they are taken in another chamber, and this chamber is the absorption tower. In the absorption towers, normally the reaction takes place in two steps. One, we have the nitrogen oxide combining with water, and it forms the two types of the acid. That is the nitric 5 acid, and in this case, nitric 3 acid. And again now, the nitric 3 acid now is further oxidized now. The air is mixed with the nitrogen oxide in this case. The air is mixed with the nitrogen oxide to oxidize nitric 3 acid to nitric 5 acid. So the air in the next step now, the nitric 3 acid here is oxidized by this air to nitric 5 acid. And in this case now, the nitric 5 acid is obtained. Now, if we can have an overall reaction which takes place in the absorption towers, we have the nitrogen oxide gas combining with water here. Once this one combined with water, to will form two types of the acid. That is the nitric 5 acid, and then we have nitric 3 acid up to here. Then the nitric 3 acid is now oxidized by this oxygen. Then we have the nitric 5 acid. So the overall equation of the reaction here, we have nitric 5, the nitrogen oxide gas combining with water, combining with oxygen. Then we have the nitric 5 acid is produced here. The acid produced here in this case, it is 65% pure. So we can have here 65%. So we have 65% pure, and then we have 35% in this case, the 35% of water. So a more concentrated nitric acid is obtained by carefully. We have is obtained carefully by use of the fractional distillation. In the fractional distillation now, it is the fractional distillation is done over either the phosphorus 5 oxide or the concentrated sulfuric acid, which is acting as a dehydrating agent. So either the concentrated sulfuric acid or the phosphorus 5 oxide, they will now remove the 35% of this water, and therefore the acid is made up to 98% pure, the more concentrated of that acid. Now, we have some of the uses of nitric acid. What are the uses of nitric acid in this case? So you will be asked to give the uses of nitric acid. You can just say that a nitric acid is used in the manufacture of explosives. Explosives in this case, you can talk about the LT. You talk of an example here, it is TNT. So we have this is TNT. TNT, it is known as trinitro-line. That is the meaning of that one. So this is an explosive. So it is used in the manufacture of explosives. You can also say that nitric acid is used in the manufacture of drugs. It can be used in cleaning of glasses. It can also be used as an oxidizing agent. It can also be used in the manufacture of dyes and very many others. So you can get some revision books or carry people to read and get more uses of this nitric 5 acid. Now, what are the environmental effects of this nitrogenous compound? The nitrogenous compound now, the nitrogen oxide gas in the atmosphere, it combines with rain, and in this case, it forms an acid rain. The acid rain in this case, it destroys buildings, it destroys stones, it causes the standard growth in plants, it destroys the chlorophyll in plants, hence lowering the growth of the plant, the growth of plants. So in that case, now that is the environmental effect of that gas. Now, how is this pollution of this gas being reduced? So the pollution of this gas is reducing by recycling of unreacted gases. So these unreacted gases are being recycled. So we have air and unreacted gases. So they are being recycled in the process to minimize the pollution effect. Then we can also talk of the treatment of sewage. to remove, in this case, the nitrogen compounds. So those are some of the ways on which the pollution effect are normally reduced. So that is a simple summary of the Ostwald process. Ostwald's process, normally the large scale manufacture of nitric acid. So you can get more of the revision books, you get more of the kcse past papers, and try to see how is the question being framed, how is the question being tested from this particular industrial process. In instances, in practical, you can talk of also the test of nitrates. Test of nitrates normally takes place in two steps. You talk of you talk of the brown ring test, and you talk of the Vander's alloy test. So those are some of the questions that you can expect in practical, and also check some cases in the familiar or past papers or any other revision books, and check on how the question is being set from this particular part. We have come to the end of our lesson, our discussion today. Don't forget to subscribe, watch, and share. Thank you.